Hey, here's part 3 of the solutions to weekly quiz number 7. Number 9, which illustration, and again, keep in mind that the number 9 that's listed here may be different in a different version of the exam. So just locate this question. Which illustration shows the correct construction of an angle bisector? That was in the Kahoot that we did. You have to know how to identify what an angle bisector is, okay? Many of us got it correct, but a lot of us got it wrong, all right? So we can definitely get rid of these two because there are not enough construction marks to indicate that either of these are bisectors, okay? A lot of people picked A because they saw these two markings. Now, an angle bisector needs to have 4 construction markings, okay? So the first one that it needs to have, and the answer choice here is C, it's not A either, is, and let me actually get my compass to illustrate this. So you'll be given an angle, and the first construction mark that you make is the arc that goes from here to here, right? And that's where you started. You made an arc, you put your focus point here, and then you make an arc here. So that's construction mark number 1. From here, you make a small arc. That's how they got that. Then you put your focus point here, make another small arc. That's how they got these two. So this is 1, this is 2, this is 3, and finally you connect the intersection of those two arcs, and so this is 4. All right, so that's why this one is the correct one. Do not choose an angle bisector that does not have this marking, because this is probably the most important mark in an angle bisector, because it tells you where to put these two markings, okay, these two arcs. All right, on to the next one. Number 10, which again might be different somewhere else. Well, it might be different in a different version of your packet. That's what I mean. Line segment RW has endpoints -4, 5, and W620. Point P is on RW, segment RW, such that RP, the ratio of RP to PW is 2 to 3. What are the coordinates of point P? So we've gone over this type of question during Kahoot and several other times. Some people came in to practice doing this kind of question for tutoring. So if you look at this number, it's large. Whenever you have big numbers like this, I always say use the formula. And the formula, once again, is x sub 1 plus a over a plus b, parentheses x sub 2 minus x sub 1. And then the same thing for y sub 1 plus a over a plus b, y sub 2, or times y sub 2 minus y sub 1. What is that a over a plus b? Well, they give you this ratio, and the ratio is 2 to 3. The 2 is a, the 3 is b. Okay, so in the ratio that they give you, right, this is a partitioning question, so this is the partition formula. That's the partition formula. And once you're given a ratio, A is the first number in the ratio, B is the second number in the ratio. And also very important, that first point they give you is always going to be your x sub 1, y sub 1. The second point they give you is going to be their x sub 2, your x sub 2, y sub 2. Okay, do not get those mixed up because that will really mess up your answer. Okay, you can't interchange them. The first point is the first point. Okay, so then just go ahead and plug in what you're given. We have x sub 1, which is -4, plus a, which is 2, over a plus b, 2 plus 3, which is 5, times x sub 2, 6, minus x sub 1, -4. Then you just solve that. 6 minus negative 4 is positive 10. Plus, take 2 times 10, and that's 20, divided by 5. That's 4. And so you're going to get 0. Okay? Now, the only answer choice that has a 0 in it is B. But I always suggest making sure that you're absolutely right. So let's take y sub 1, which is 5, plus a over a plus b, which is 2 over 5, y sub 2, which is 20, minus 5, 5 plus 2 over 5 times 15. So 2 times 15 is 30, divided by 5 is 6. So 5 plus 6 is equal to 11. And so we're sure that that answer is correct. All right. On to number 11. Practice working with this formula. Just practice it. You can go on, you can just look at using the partition formula just to pull up some questions using the partition formula if you just want some practice with it. Okay. All right. I don't expect to see anybody get that question wrong. I feel like we do that question so many times in life. It's just a lot. All right, so the next question says, as shown in the diagram below, segment CD is a median of triangle ABC. Which statement is always true? A median is a segment in a triangle with one endpoint, that's sloppy, one endpoint on a vertex, which this one has, and the other on the midpoint of the opposite side. Okay, so a median is a segment in a triangle with one endpoint on a vertex and the other endpoint on the midpoint of the opposite side. So this is the vertex, this is the side opposite the vertex, D is the midpoint, because that's what a median does. One endpoint is on a vertex, the other endpoint is on the midpoint of the side opposite that vertex. So by this being the midpoint, we know that these two are congruent to each other. And so that's the case. Segment AD is congruent to segment DB. Therefore, that's your answer. Okay. In the accompanying diagram, B is the midpoint of AC. B is the midpoint of AC. Okay, so that means these two are congruent. DA, segment DA is perpendicular to segment AC. We see that indicated by that 90-degree angle. Segment EC is perpendicular to segment AC, which is the 90-degree angle that's created here. And DB is congruent to EB. Okay, so these two sides are congruent, and that's why I think it is important to annotate. DB is congruent to EB. All right, so if you take a look at all the annotations that I made, which method of proof can be used to prove these two triangles are congruent? So a lot of folks thought it was side angle side. Is that the case? Can we use side angle side? Well, we do have a side, right? And an angle and a side. A side, an angle, and a side. The answer was, in fact, hypotenuse, leg. And let's see why that is. Let's see why that is. And I actually might have to grant people some credit here because it looks like it technically could have been side angle side. It looks like it could have, but why can't it be? Because we have an angle in the middle, and then is this why? Because it's side angle. Oh, yeah, that's what it is. So if it was side angle side, then our congruent sides would be right here. So it would be a side here, an angle here, and a side here. But this is not smack in the middle of two congruent sides because, like I said, if that was the case, these two would have markings, these two would, and so it would be side, angle, side. In this case, it's angle, side, side, angle, side, side. Yeah, so it wouldn't work as side, angle, side. And ASS does not work. Neither does SSA. So the reason why it could not be side angle side is just because of where the congruent sides are located. Had they been over here, you could have definitely used this, but they're not, unfortunately. So you have a hypotenuse, and again, the hypotenuse is always located directly opposite the 90-degree angle, and hypotenuse leg states that if you have a pair of congruent hypotenuses and a set of legs that are congruent, which in this case are A, B, and B, C, then you can prove by the hypotenuse leg or RASS theorem that they are congruent. And that says right angle side side, which is right angle side side, right angle side side, or hypotenuse leg. Hypotenuse leg. Okay. Stay tuned for part 4, the final part.